Hello everyone. In this video, we will be talking about the static routing. As you know, static routing is the process in which different routers makes the routing table, for which either we can use the dynamic routing which is available to us, or we can always use the static routing process. So the basic process which is involved for that is there will be certain routers. So for simplicity, I will be taking 3 routers here like this. Those routers will be connected with that of certain switches, which I am taking as SW1, SW2, and the last one is SW3. And these switches will be further connected with that of the PCs, which I'm taking as PC1, PC2, and PC3. As you all might be aware that in reality, we will not have only just one PC attached with that of a switch. We will have the multiple PCs attached. But for the simplicity, and I am using only the bare minimum pieces. So it will help us out in understanding the static routing in a better manner. So the next thing that we are supposed to do is we need to assign IP address to all the ports. The first thing that we need to do is we will assign one IP address to the PC. Then the subnet mask will be assigned to the PC. The third important thing is you need to assign the gateway address to the PC also. So the gateway address for my PC1 will be the port address of this router. I am taking that gateway address as 10.10.10.1. So that same address will be assigned to this this router. Similarly, I will be assigning the IP address 20.20.20.2 to PC number 2. Subnet mask will also be defined and the gateway will also be assigned, which will be 20.20.20.1. So same address will be assigned to that of your this port number, which is put up in the gateway address of the PC2. Similarly, we will be assigning IP address 30.30.30.2 to the PC. Subnet mask also will be assigned automatically. Gateway will also be taken as 30.30.30.1, and that same address will be assigned to this port number of the router. So this is the first basic configuration which will help us out in forwarding the data from PC till this particular port number. So now my data packet can travel from PC1 to router interface. But till now we have not defined any path with which the router will be able to forward their data further to the next routers available in the network. So for that we need to use some routing mechanism, right? For the routing mechanisms, we need to assign IP addresses to these ports also. For the sake of simplicity, I will be taking this network as 40.40.40.1 and I will be taking the first as 40.40.1. Similarly, I will be taking the second IP as 40.40.40.2. And this network, which is there between router 2 and router 3, that I will be taking as 50 network. That will be 50.50.50.1. That will be the address of R2. And similarly, I will be taking the IP for router 3 as 50.50.2 for router 3. And there is one thing more that you need to notice, that the link between these will be the serial link, not a normal link. So we need to have the serial link between R1 to R2 and from R2 to R3. So we will have a serial connection between these routers. Along with that, there is one very important thing that you need to understand, that whenever we are using any serial port, we need to set the clock rate also. So we need to set the clock rate to 64,000 for this serial port, this one, as well as this one. This clock rate will help the routers to be in sync with one another so that they match the speed of one another. They are in the synchronization while receiving the data from one another. That is all about the basics of your routing. But till now, I have not explained that how will the routing happen. For understanding the routing, we need to use Cisco Packet Tracer. So let me share my Cisco Packet Tracer screen with you, which will make the things more clear with you. So the first thing that we are supposed to do is, we need to take the routers. I am taking a generic router here. So this way I will be taking 3 routers like the one I draw earlier also. Then I have to take 3 switches. I'm using 295024 switch. We require 3 PCs also. The next important thing that we have to do is, we need to make the connection between the devices. Every device should be connected with that of the appropriate device. So I am attaching this switch with that of the router. Similarly, we'll do for the third one also, where I am attaching my PC with switch, and further the switch is connected with that of a router. Right now you can see that the dots are red. These dots are red because the connection is not established yet. So you can very well see, when I chose this automatic connection between these routers, the wire appeared to be a serial wire. The next thing that we have to do again is, we need to assign IP address to the device, which I have already shared with you. The IP address which I will be taking for this will be 10.10.10.2, and the gateway address for this will be .1. Now this same gateway address will be taken as the address for the the normal port for the router, which is FA0/0. For that, I will be using 10.10.1. And one thing is more important here, that you need to switch on the port also. Till the time you do not switch on the port, it will not be working fine. Similarly, we'll assign the IP address to the other devices, which I am doing right now. Now you can see that we have assigned the IP addresses to all the devices. We are done with assignment for the IP address for PC6, PC7, PC8, as well as we have assigned the IP addresses to FA0x0 interface for these routers. So our data will be able to be forwarded from PC6 till this port number. But further, it will not be able to travel. So for that, we need to assign few more IP addresses. For that, I will be assigning some IP addresses to the serial interfaces. So the serial interface of this port is serial 2x0. The first thing is you need to assign the port status as on. Then you need to assign the IP address, which I am taking as 40.40.40.1, and you will press cross. Do not forget to put up the clock rate also. Whatever clock rate you are taking in this router interface, same clock rate is supposed to be put up in the other serial port in the parallel router. So the address for this is 40.40.40.2. Subnet mask will be assigned. And important thing is about the clock rate, which I have just set to 64,000. So now you can see that the dots are green now. So we are done with the assignment of this one. And now you need to assign the IP address to the next serial port. If you are not sure that which particular port it is, you just need to take your cursor over your link and it will show you the label, which will help you out in enabling that port and assigning IP address to that. So this one I am taking as 50.50.50.1. Again, the same procedure, do it for 60, set the clock rate to 64,000. Similarly, we need to assign IP address to the next serial port, which is SE2x0. We need to go to SE2x0, switch it on, assign it IP address 50.50.50.2, subnet mask, and the clock rate as 64,000. So now you can see that we have made all the connections, but then also we will not be able to forward the data because till now we have not done any routing. For doing the routing, we need to go to this first router. When we go to this router, there you need to go to the static routing. In the static routing itself, you will see that there is one tab on the left of which you can see static routing is written. Along with that, there is this network address. This network is the address of the destination. Then you have got this mask and the next hop. So we need to send the data from PC6 to suppose PC7. So whenever the data has to travel from PC6 to PC7, the network in which the PC is, it is 10.0.0.0 because all the IPs of all the PCs on this network will be in this range only. And this one is 20.0.0.0. So in the destination address, we need to give the address of 20 dot something. So let's start with that. So the destination address in this is 20.0.0.0. The mask is, we need to put up the subnet mask manually here, otherwise it will not appear by itself. The next important thing is about the next hop. Next hop is the IP that if you have to send data from PC6 with the help of gateway address, the address of this port is given. So data will reach here, but you need to tell it to your router that from this port to this port, what will be the next hop. The next hop for this one will be this particular serial port, for which we have taken the address as 40.40.40.2. So we need to assign the IP address to the next hop. The IP is already assigned. We need to just put up the values in the root. So it is 40.40.2. And then we need to just click on the add. Once you click on the add, the network address will be added. But please try to understand that whenever we are trying to forward the data, we need to give the routes in both the ways. As of now, we have given the route to send the data from PC6 to PC7. But till now, we do not have any method available with which your PC7 will be able to reply back to that. For that, we need to go to the second router here. We need to go to the static routing of this router, and along with that, we need to follow the same procedure where we will assign the destination network address. So the destination for PC7 will be 10.0.0.0. Mask is 255.0.0.0. And in the next hop, we need to assign the IP address of router 6 and the serial interface of it. So I will add the route in the routing table. Once you are done with it, let's check whether the link between PC6 to PC7 is working fine or not. For that, I will take one simple PDU, drop it on PC6, that will become our source, and PC7, that will become our destination. Then we need to go to the simulation mode, click on the auto capture play, and let's see whether it works fine or not. Now you can see the packet is traveling from PC6 and it has reached to router 6 now. Further, it has gone to router 7. It means till that the link is working perfectly all right. Now it is there with switch 8. From switch 8, it has gone to PC7. And from PC7, the message is being resent back. Now it is there at router 7. It will go back to router 6. And finally, it will go to switch 7. And from there, it will land at PC6. And you can very well see that in the status, the simulation is saying that it is successful. You can very well see the simulation is successful. So this way, you will be able to forward the data from one network to another network. We were able to forward the data in this network with the help of static routing, where we put up few static addresses and made the routers intelligent so that they can forward the data further from one network to another network. Similarly, we can repeat the same procedure between router 7 and router 8, and we will be able to forward the data from PC7 to PC8 also. So this is all about today's lecture. In case you are facing any problem while doing it, you can put up your messages in the chat box. You can put up your comments. I'll reply back to you with the solutions in the next video. Thank you so much for watching. Have a good day.